So now we're going to move on to multiplying polynomials. So we're going to work on multiplying different forms of polynomials like two monomials, a monomial, binomial, all that fun stuff. And we're going to work our way through it. So I think the only thing I don't have in here is this very last bit I pulled off. So to multiply monomials, we first multiply their coefficients, then we multiply their variables using the rules of exponents and the commutative and associative laws. So basically, this is going back to just rules of exponents, what we had done there. And most of what we're using is these rules. It's just this one here. They have the same base, but different powers. I can add those powers. So I have two monomials here. I have 3x squared y to the 7th times 4xy cubed. So by commutative property, I can rearrange this because it's all multiplication. And we don't need necessarily do this, but if it makes it easier, I can arrange it so my coefficients are next to each other now. My x's are next to each other. And my y's are next to each other. So 3 times 4 is just going to be 12. Then I have a x squared, and I have an x to the power of 1. So we just add those powers. And then I have y, so y has the same base, y to the 7th, y to the 3rd, so I just add those powers. So this could just be simplified into 12x cubed y to the 10th. Okay, and remember, we're multiplying this, and so when we talk about simplifying, what we're really getting at is that we just want to make sure that we have, don't have parentheses, limit the number of coefficients we have, limit the number of variables we have hanging around, just try to make things as simplistic as possible. Distributive law is the basis for multiplying polynomials other than having monomials. So we have a monomial, and this is not a binomial. This has got two terms. We call this a binomial. So if I have a situation like this, remember what distributive property says? Is that if I have addition or subtraction and I'm multiplying to it, I can distribute the multiplication across. That's what we're going to do here. Is I can distribute this across this. So I can rewrite this as 2a squared b to the 7th times 3ab minus a b, 2a squared b to the 7th times 6a squared b cubed. So this is just 2 times 3, and then we have a squared times a, b to the 7th times b, and then here we have 2 times 6, a squared times a squared, b to the 7th times b to the 3rd. So we get 6, a to the 3rd if we add the exponents, and we get b to the 8 if we add the exponents, minus 12, a to the 4th if we add the a exponents, and b to the 10th if we add the exponents. So when I have a monomial, I'm just distributing it across. So it needs to multiply to the other terms of the other polynomial, in this case, a binomial. So if we have, let's say, two polynomials that are not monomials, then we are going to have a repeated use of the distributive law to enable us to multiply any two polynomials regardless of how many terms are in each. So if I have this case here, what I can do is I can take all this and distribute it to each term. So what I can have is 7x squared, but I'm going to multiply that 3x plus 2 to it. I have that negative 2x, and I'm going to multiply 3x plus 2 to it. Then I have that 1, and I'm going to multiply 3x plus 2 to that as well. So that was the distributive property used once. Then I can use it again, because here we got 7x squared times 3x plus 2. So we're going to distribute another time. My tools are not cooperating. There we go. So if I do that, I'm going to have 7x squared times 3x plus 7x squared times 2. And then I could do that again for the next term, or next part of this. I have negative 2x times 3x plus 2. So I'm going to distribute this negative 2x across everything. That's going to give me a negative 2x times 3x and a negative 2x times 2. And this one's a little silly, but technically I can distribute this one across here. So we're just going to do it for demonstration's sake. For that case, I'd have 1 times x squared, 3x, plus 1 times 2. So once I did that, all I have to do is just combine everything, simplify each term. So this one simplifies into 21x squared cubed. This one is 14x squared. Then I have minus 6x squared minus 4x plus 3x plus 2. And then to simplify completely, we have like terms here in here. So this is just 21x cubed plus 8x squared minus x plus 2. So you probably don't want to keep doing this in several stages. So we're going to kind of show us have little different ways to handle this multiplication. But first, before we get into other ways of doing this, you're going to multiply two monomials. And then you have B here where you have two polynomials. So you're going to have to do that, multiplying one polynomial across and then distributing a second time. Okay. So for A, 3 and then negative 5, we put those together. The x squared and the x cubed go together. The y to the 5th and the y go together. This will give me negative 15. X to the 5th, y to the 6th. Now B is going to be a bunch of extra work. So I'm going to take this whole thing here and distribute it across. So once I do that, I get x squared times 5x cubed plus x squared plus 4x. Then I have plus 3x times 5x cubed plus x squared plus 4x. Now the next fun part is I'm going to distribute this x squared across to everything. And then this 3 gets distributed across, 3x gets distributed across everything here. So once I do that, I'm going to have 5x cubed times x squared times x squared, 4x times x squared. Then for over here, plus 5x cubed times 3x plus x squared times 3x plus 4x times 3x. So if we simplify that, we get 5 x to the 5th plus x to the 4th plus 4x cubed plus 5x to the 4th plus 3x cubed plus 12x squared. So once simplified, we do that again. We get 5x to the 4th. So we have our x squared, or again, 5x to the 5th. We have an x to the 4th and an x to the 4th. I'm not trying to talk about two terms at the same time. We get 6x to the 4th. We have a cube and cube together. So if we add those, we're going to end up plus 7x cubed, and then we have the 12x squared.